we talked about a couple different methods of solving linear systems of linear equations. One of them was substitution and one of them was elimination. Remember, when we used elimination, what our goal was, what we were looking for, was opposites. So what did I mean by opposites? Let's say we had 2x. What would the opposite of 2x be? Negative 2x. That way they would cancel each other out. So another example, what if we had negative 3y? Well, we would want to have the opposite of that, which is positive 3y. We're going to be looking at three variable systems today. However, we're still going to be looking for opposites. We're still going to be looking for variables to cancel out, just like we did when we used elimination previously. We have a system of equations with three variables here, and it looks like everything's lined up in standard form. So that means elimination might be a pretty good method to try, and when we use elimination, we need to find opposites. What's tricky about these types of equations is there's so many variables to have opposites for, it's hard to kind of figure out which ones you want to use. But if we look really closely in the middle, we can see that we already have opposites. We have 2y and negative 2y. So I'm going to go ahead and combine those two equations to get those y's to cancel out. So I'm going to rewrite it so you can see what's going on. We're going to have x plus 2y plus 3z equals negative 2. We're going to have 2x minus 2y plus z equals 7. Those are the two equations we're going to use to solve. That was minus 3z, wasn't it? Yes, sorry. Fixed. Alright, let's go ahead and combine these two. We are going to end up with 3x's, no y's, and negative 2z's equal 5. Okay, so we've eliminated the y by using equations 1 and 2. We need to eliminate the y somehow using equation 3. So we have y in equation 3. We need to get opposites using one of the other two equations. I'm going to use equation 2 since it's already negative. We just need to make the third equation have 2y in it, and we would have opposites. So we're going to need to multiply the third equation by 2. I'm going to go ahead and do that and rewrite my equation over to the right. So we're going to have 2x plus 2y plus 4z equals negative 8. And then I'm combining that with equation 2, so I get 2x minus 2y plus z equals 7. Now we can go ahead and combine these two equations. So we get 2x plus 2x, which is 4x, 4z and z, which is 5z, equals negative 8 plus 7, which is negative 1. So now that we have these two equations with the same two variables, we can write those as a two-variable system and solve using methods we've already worked on. I'm going to go ahead and move to another slide so that I have more room to work, and I'm going to copy these over. Okay, I went ahead and copied our two systems, the original system and the new system we got. I want to go ahead and eliminate either x or z from my new system, and to do that I need to find opposites. In this case, 4x and 3x is not opposites. Neither are the 5z and the negative 2z. So I'm going to end up needing to multiply both equations. Since we already have a negative sign with the z's, let's go ahead and eliminate those. I have the numbers 5 and 2, so 10 would be a good goal to shoot for. If we multiply the top equation by 2, we'll have 10z. If we multiply the bottom equation by 5, we'll have negative 10z, which will give us opposites. So when we multiply, we get 8x plus 10z equals negative 2. And we get 15x minus 10z equals 25. That is so a z, I swear. Alright, when we combine these two equations, we're going to get 23x. Can't write today, I'm sorry. Z's cancel, equal 23. Divide both sides and you get x equals 1. So we can go ahead and write that in our ordered triplet where x goes. I'm going to go ahead and write the whole thing so we see that, oops, we still need y and z. So to find z, we can use our smaller system again. So we can use any of the four equations we have. I'm going to choose to use the top one. I'm going to plug in the value of x. So 4 times 1 plus 5z equals negative 1. 4 plus 5z equals negative 1. Now this is just solving. Subtract 4 from both sides. So 5z equals negative 1. Divide both sides by 5 and we get our value of z, which is negative 1. So I'm going to add that where it needs to go as well. We have x, we have z, we need to find y, and we need to do so by going back to our original system. So if we go back to our original system, we can use any of the equations. We're going to choose to use the third one because it looks the simplest to me. Doesn't matter which one you use, you're going to get the same value for y if you do your math right. So x, which is 1, plus y, plus 2 times z, which is negative 1, equals negative 4. So 1 plus y minus 2 equals negative 4. Here's where we can combine like terms. Y minus 1 equals negative 4. Add 1 to both sides and we get y equals negative 3. So we're done. We have our final variable that we were looking for. These three planes meet at the point 1, negative 3, negative 1 in three-dimensional space. Another system where everything is all lined up. Let's try to do some elimination. I have x and 2x and x. I have 2y and y and y. And look at our z's. Ooh, we already have opposites. Now, you could certainly change one of these equations to make opposites of x's or opposites of y's. But if we already have opposites, let's go ahead and go with that. So I'm going to use equations 1 and 2. What does this mean about the third equation? This means that the next step, the next thing I do, will involve the third equation. So I'm going to rewrite those first two. I can see exactly what's going on with my elimination. Alright, so when we combine these two equations, we're going to get 3x plus 3y, z's cancel, equal 12. Now we're down to a two-variable system. We can't totally finish solving yet, but we can get another two-variable equation and make that two-variable system. So we've used equation 1 and 2. We need to use equation 3 at some point. We need opposites. I'm going to use equation 2. Looks like we can make, oh wait, yeah, let's use equation 2. I can make opposites with my z's, which is what I need to cancel out. Since I chose to cancel out z initially, I have to continue that. I have to be consistent. I can make opposites on equation 2 by multiplying by 3. That way I'll have 3z from equation 3 and negative 3z in equation 2. So I'm going to go ahead and get a new color and rewrite that equation over to the right. 6x plus 3y minus 3z equals 12. Now remember, we had to use equation 3, so I'm going to rewrite that as well. X plus y plus 3z equals 7. Now I can go ahead and combine these. 6x and x is 7x. 3y and y is 4y. Negative 3z and 3z cancel. And on the other side, it looks like we have 19. So we have our two variable system all ready to go. There's one equation, there's the other equation. I'm going to rewrite these again on a clean slide so that we can finish our elimination process and find the points, the solution points for this three variable system. Okay, let's focus on the two variable system. 7x and 3x and 4y and 3y. No opposites. We need to make opposites. Looks like we're going to be stuck with multiplying both equations by a number. We're going to choose to get rid of the y's because 4 and 3 are smaller numbers. So we need to make opposites of 4y and 3y, and to do so, 12 would be a good number to shoot for. One of them has to be negative and one of them has to be positive. It doesn't matter which. I'm going to choose to make the top positive 3, so that'll give me positive 12. And the bottom is negative 4, so that'll give me negative 12. So now I'm going to multiply these out and get my new system. So my new system will be 21x plus 12y equals 19 times 3, 57. And then in the bottom, or the second equation, we're going to have negative 12x, negative 12y, and negative 48. Now we can go ahead and combine these two equations. 21x minus 12x is 9x. 12y minus 12y, 0. 57 minus 48 is 9. Divide both sides by 9, and we get x equals 1. So we already have one of the three numbers we're looking for in our solution. And to find either y or z, we need to just work our way backwards. Let's find y next, since that's what's in our two variable system. What I'm going to do is pick one of the four equations to plug my x value into. I'm going to choose the second original equation because it's smaller. 3 times x plus 3y equals 12. So 3 plus 3y equals 12. Subtract 3 from both sides, so 3y equals 9. Divide both sides by 3, and we get our value of y, which is 3. So I have x, I have y, I need to find z. And to find z, we need to go all the way back to the original equation. And we can use any of the three equations. It doesn't matter which one we get to decide. I'm going to use the top one. You can do the same thing with one of the other ones and double check. See, do you get the same value for y that I do? It would be kind of a good little test. So, x is 1 plus 2y, which is 2 times 3, plus z equals 8. So 1 plus 6 plus z equals 8. 7 plus z equals 8. And subtract 7 from both sides, so we get our value of z, which is 1. So these three planes cross, or intersect, at the point 1, 3, 1. One more system for us to look at solving elimination with. So, look at your x's, look at your y's, look at your z's. Do you see any opposites right away? I don't either. That means we're going to need to make opposites. And we can use any combination of two of these equations to make opposites. Doesn't matter. I'm going to choose to use the second equation and the first equation. It looks like these two I can make opposites pretty quickly with my x's if I multiply equation 2 by 2. So let's see what happens when we do that. We're going to have negative 2x minus 4y positive 2z equals 8. And then I'm going to rewrite equation 2, so we get 2x plus 4y plus, minus 2z equals 4. That's a minus sign, I swear. So when we combine, 2x and negative 2x cancel. 4 and negative 4 cancel. 2 and negative 2 cancel. Shoot, what's left over? If you have nothing on one side of the equation, you have 0. So 0 equals 12. Uh-oh, special case. So we need to ask ourselves, when does the number 0 equal the number 12? And the answer is never. So there is no solution to this system. Remember, you can write no solution, or you can write that symbol 0 with a slash through it. That also means no solution. There is no place where these three planes, all three of them, actually intersect. So this was solving three variable systems using elimination. Again, we needed to find opposites. We just had an extra step involved when we had the third variable. However, the different skills we used were still the same. Looking for opposites, eliminating variables, and plugging back in to find our other missing variables.